Hi everyone, this is the video number 1 for lesson 6.1. So the front is the exploration. We're not going to do that in this video, so I want you to flip over to page 2 and we're going to start with some vocabulary. So as you hopefully learned a little in the exploration, we're looking at a new kind of function called an exponential function. And the reason it's called an exponential is your variable, your x, is an exponent. So whereas you're used to things like this, a quadratic, there's your variable, a linear, there's your variable. But when it's an exponential, your variable, your x, is actually an exponent. And then this is your y. So for example, this is an exponential. You may or may not have a number out front here, the a. The b is the base, just like we were talking about in our introduction unit. So the base is going to be a number, and the variable is always going to be stuck up here as an exponent. So there's two kinds of exponential. There's either growth or decay. So when it's growth, the b, the base, is always going to be greater than 0. For example, b will equal something like 1, 2, 3, ... something greater than 0. Something greater than 0. Okay, so they're going to look like that. There's your b, it's a 3 to the x. Another example where we have a number out in front. Doesn't matter, I'm just making this up. So this would be 2 to the x. Just another example of growth. So what is the growth factor? The growth factor is b. So just how much is it growing for? So in this case, it's growing by a growth factor of 3. An asymptote, we're going to write the definition and then I will show you on a graph on the next page. So what you want to put here, an asymptote is a line that a graph approaches more and more closely. So a line that a graph approaches more and more closely. I want to remind you that everything in these notes you can also find in the Big Ideas online textbook. So an asymptote is a line that your graph, I'm just going to show you on this, you can just watch this, that your graph gets closer and closer to. So if you think the x-axis here is a line, and this exponential decay function, see down here, it's getting closer and closer and closer to the x-axis. It actually, if I were to think about this blown up a little bit, it's doing this, it's getting closer and closer and closer, closer to this horizontal line. It never reaches it. So this horizontal line is what we call the asymptote. So we'll talk about that more as we look at graphs. An exponential decay function is going to have a b, a b that is between 0 and 1. So I like to think of these as measuring cup numbers. So the numbers on a measuring cup, your measuring cup is either empty or it's at 1 cup. So if b is a number on the measuring cup, then you know you have a decay. Like here's your b. How do I know this is the b? Because it's got the x attached to it as an exponent. The 2 is not my b because it doesn't have an exponent of an x up there. So this is my b. 1/2, that's a number on the measuring cup. Then right away I know that is decay. And so the decay factor again is the b. So you would say this is decaying by a factor of 1/2. All right, this is just a little review that will help us when we start graphing these guys. This says evaluate the expression for x equals 2. So for each of these, we're going to replace x with 2. So instead of 3 to the x, it's going to become 3 to the 2, which is 9. Instead of 2 to the x, it's going to become 2 to the 2, which is 4, or I should say 2 to the 2nd power, or 2 squared. So every time I'm replacing the x with a 2. So this one, 1/3 to the 2nd power is the same as 1/3 times 1/3, which is 1/9. So don't put those in your calculator and give me a funky decimal. You can go ahead and do that out and keep it in fraction form. So that's just a little review to help us when we graph. Now this is, hey, I'm giving you a function and I want you to tell me if it is growth or decay. So remember, what determines if it's growth or decay is the base, the b. So here's my base. So for this first one, b equals 2. 2 is greater than 1. So this is growth. We're going to back up here, guys. I have a mistake up here. That's why I paused when I was saying this. This should be exponential growth is greater than 1, or it should actually be greater than or equal to 1, because it can equal 1. So go back up in your notes and fix that. That should not have been a 0. I apologize for that. Greater than 1. All right, so let's look at this next one. This is my base. I know it's my base because it's got the exponent, that is a variable, attached to it. So b equals 3, which is greater than 1. So this is also growth. And again, this is b equals 4. That's clearly greater than 1, so that is growth. So that gives you an idea of what your growth functions will look like. Now I'm going to tell you right now, these are all decay. And if you look at your base in all of these, 1/2, 1/3, 1/4, those are all measuring cup numbers. So in the first one, b is 1/2, and I want you to think, is that a number on the measuring cup? Yep. Oops. So whenever you have your base that is a number on the measuring cup, it's going to be decay. B equals 1/3, definitely a number on the measuring cup, third of a cup. Decay. B equals 1/4, oops, decay. Okay. We'll quickly go over these graphs, and then I think we will just have this video be the vocab, and then in the next video I'll do some examples. So these are your two functions that you can think of, your parent functions. So this is growth, a growth function, and this is a decay function. So growth functions will always have this, exponential growth functions, I should say, will always have this general shape. So as you're moving from left to right, your graph is going up. Or I like to say, as x gets bigger and bigger, your graph is going up toward infinity, right? So this is what a growth function will always look like. So this says the x-axis is the asymptote of the graph. So here's the x-axis, and on this side our graph is approaching the x-axis, but it never crosses it. So it says an asymptote is a line that the graph approaches more and more closely, just like what we wrote in our definition. The graph rises from left to right. So as I go from left to right, if I follow my graph, it's going up. So that means it's growth. Passing through the point 0, 1, that is kind of a special point. It is your y-intercept. And another point on the graph is going to be 1b. That will make more sense when we start graphing these. Okay, so that's a growth. And notice up here it said b greater than 1. This is a decay. So as you move from left to right, this one's going down from left to right. So as x gets bigger and bigger, your y values are going to get smaller and smaller and smaller. We'll see that when we do some graphing. So same asymptote, the x-axis, same y-intercept, 0, 1. Decay, growth. Okay, I am going to stop, and the next video will have the examples in it.